Hi everyone, welcome to Neuroscience webinar, and today we'll be talking about the frontiers in neuromarketing with the insights from the Barcelona IQS Neuro and Digital Lab. And I'm very happy today to welcome our guest speakers. We have today with us Drs. Matute and Dr. Meyer. Good to have you here, guys, Jorge and Jan.
Thanks for having us.
Yeah.
Thank you very much.
So just a little housekeeping. Before we get started, we'll begin with the lecture with the duration of approximately 45 minutes. And this will be followed by Q&A. And as always, please feel free to submit your questions at any time using the Q&A tool that you have in Zoom. So before we go to the presentation, let me quickly introduce the topic of the webinar and our speakers. So neuromarketing represents cutting-edge approach to understanding consumer behavior, merging neuroscience with marketing strategies and to gain deeper insight into consumer decision-making process. And through this seminar that we'll have today, Drs. Matute and Meyer will present the IQS Neuro and Digital Marketing Lab. We'll explain its different opportunities for academia and researchers, what they are doing. The Neuro and Digital Marketing Lab is an innovative space that uses technology from the company iMotions and also from Neuroelectrics, and in which professors, researchers, companies, and students collaborate with the aim of advancing the knowledge of consumer behavior through the use of different neuromarketing techniques. One of these techniques include EEG, electroencephalography that we provide at Neuroelectrics, but also galvanic skin response, facial identification of emotions, different eye tracking devices, and other techniques. And through different examples, both our speakers will explain how they are using the lab to enhance research, train students, develop consulting projects with companies from different sectors. So I'm very happy to welcome Jorge and Jan, and the stage is yours.
Thank you, Rafa. So good morning, good afternoon, good evening, everyone. We are going to start. We are Jorge and Jan, and we are going to be introducing today our Neuro and Digital Marketing Lab through this nice webinar. Thank you to Neuroelectrics for giving us this opportunity of presenting these frontiers in neuromarketing. All right, we are going to explain a little bit our experience. The idea is that we can share with you how has been the process for us in order to design a new lab from scratch, and to share with you all the experience that we had using also different examples of how we are using the different devices and technologies that are present in our lab. So today's agenda, it's going to be basically to try to explain this experience. We, Jan and myself, we are professors, we are teachers, but we are also academic researchers in the area of consumer behavior that we use neuro and biosensors for different academic activities. So we are going to divide this presentation today in different sections. First of all, we are going to talk about our ring, our precious ring, which is our Neuro and Digital Marketing Lab at IQS School of Management from Universitat Ramon Llull, which is a university that is located in Barcelona. Then we will explain a little bit about the priority, and we will define why this is a priority for us, which is teaching in this laboratory. We will explain a little bit about the opportunity, consultancy projects, and we will also share with you, which is our truly academic passion, okay, which is doing scientific research. And finally, we will do a little bit of wrap up by sharing with you a little bit more about our experience and to provide you with some tips if you are in this line of considering to use this kind of technology for your academic activities. So let's start, first of all, with IQS from Universitat Ramon Llull. And actually, IQS stands for Instituto Químico de Sarriá, which means that this Q stands for chemical. So this means that our students, especially from the studies of engineering or of chemistry, the first day that they come into the class, into the school, they go to the lab. So teaching is very, very experiential. There are many different facilities and laboratories basically for teaching in the area of industrial engineering. They have super nice cars and motorbikes and 3D printers, bioengineering, different types of engineering studies. So basically, there are a lot of labs. The problem is that we have a second school, which is IQS School of Management, and that's where we are. So when this idea started? Well, it was basically around 2021 when the board of the school basically came to us and they asked us to create something where the students of IQS School of Management could also have this experience, could also be having this experiential learning in the business school. So basically, what they proposed to us is to create a lab, a space, a great room that combine initially teaching activities, right? That's the priority of a private university here in Spain, with academic research, and explore the possibility of also designing some transfer knowledge activity. That's what Jan and myself, we call it, and using this quoting from the Lord of the Rings, one lab to rule them all. So that's where we were then. In 2021, Jan and myself, we started to design this space, this laboratory. We started to train ourselves, attending the emotions, and then we started to explore how to create this laboratory.
Right. The space that we built is a unique space, at least in Spain, because we have this teaching focus. So we were able to secure a big classroom of 104 square meters. And basically, we have opportunities to teach up to 54 students, but we also have a section that is purely dedicated to research. As you can see on the picture in the back, you see the classroom and you see the glass wall behind it. This glass wall, behind the glass wall, we have the academic or the research-based part. It's connected and it can be obscured with curtains, but it can also be uplifted, the curtains, and be integrated into the classroom. So it's a very unique lab because many universities have neuro labs, but very few universities have neuro teaching labs, especially in the sectors of business. Many business schools have similar equipment than we do, but not many bring this to students. So of course, this is also risky, and we are the ones that take that risk. Basically, overall, we have 26 computers in that room, 19 for students, which are a little bit lighter, the ones that are integrated into the desktop, as you can see in the picture on the right. And we have some more heavy computers in the back, in which we would use to analyze and collect data. So this structure, to my knowledge, is quite innovative and not present in many universities. And this is what this is also how we convinced the board to invest in this laboratory, because if research is nice and academic research in business is something that, as Jorge said, is our passion. However, it's not what generates revenue to the school. It might generate prestige to the school, but not revenue. Revenue is brought to the school by the students, right? And if we do not bring this lab to the students, and if we do not put this lab as an interactive experience, there's no way to get leadership buy-in, at least from our institution. And I've heard similar voices from other universities that this is a viable approach in the end. This is a little bit more of an overview how the lab looks like, as I already had explained. So on the top left, we can see a picture out of the research part in the back towards the classroom, where we can see the different tables where students can collaborate. It's a collaborative work environment where student teams of 2, 3, or 6 can work on one table and work on this stuff together. Stuff is complicated and advanced, so it's always better to put students together. Otherwise, they will always have every question to answer. On the right, we see the cubicles where we collect data. This is a setup from a study where we use the voice assistant and our lab computer setup. Yeah, and basically on the bottom right, you can also see again the research area and how it's with the double glass integrated into the classroom. So we can put down the blinds and actually collect data while we have a class, instead of for instance, we can pass student by student to participate in a study in the back while we teach something in the front. At least if the class is not super loud, in the sense that if somebody with a very loud voice like me is speaking, it's complicated to also collect data in the back. But in case we have a silent class where they just work in teams, it's very easy to ask them one by one to come to the back or in pairs and participate in an academic or in a consultancy-based study or in a class project, for instance. So it really brings the academic, the research part to the class experience in the end.
So this is a little bit any given day in the laboratory. This is what we do almost every day. Jan and myself, we spend a lot of time in the laboratory because we did a lot of different courses at different levels, at the graduate programs, also at the master's programs. All right. So we basically have this space, a collaborative space for teaching, doing academic research, and also looking for synergies also to collaborate with companies that sometimes come to the lab and they participate in the different courses that we teach to the students. These are some pictures just for you to illustrate a little bit what we do and what we have in the laboratory. So speaking about teaching, but let me first start with the software. Basically, the heart of the laboratory is it's emotions, which is a more research-oriented software that probably you are familiar with, right? Emotions, it's mostly the heart of our laboratory, and it's a package that allow us for the integration of the different neuro and biosensors, right? So we can have this information coming from different senses, right? Especially from the brain, or we also measure some KPIs from galvanic skin response. We also implement Affectiva, which is a software for identifying facial emotions, okay, or emotions that are revealed through facial expression, all right? And within emotions, we also use, of course, neuroelectric devices, okay? Our hardware for the electroencephalograms, it's basically products coming from neuroelectrics that we will explain a little bit more about them a little bit later. But basically what we have is facial coding algorithm, eye tracking, via webcam that allow us to also do some online studies, voice analysis algorithm, galvanic skin response, and the EEG, the neuroencephalography with neuroelectrics. What do we have as the heart of the lab? We have 4 full licenses that allow us for multimodal data collection, right? We don't really need more for what we are doing right now. But we also have 1 online license. The online license, it's a variation of the emotion software that allow us to collect large-scale data, but obviously it has 1 disadvantage, is the fact that you can only collect data coming from facial coding and webcam-based eye tracking, which is a little bit less accurate than the traditional eye tracking, but still is a good option if what we are looking is for scale. Right? And also we have 25 student licenses that are mainly for teaching purposes, where students can design different types of experiments and analyze data. They are not allowed to collect data with this kind of licenses, but they are still able to perform some interesting tasks when learning about neuromarketing.
The beauty about emotions is that it's given the field of neuro, it's rather intuitive, and students can actually understand what they are doing. If in our business school we were to teach students R scripts and Python pipelines to process data, we would not be able to reach results during a normal class. And that's the beauty of having emotions and everything in one place and the same interface for each sensor. So this is the big advantage why we opted for this particular software provider. In terms of hardware, this is basically what we have in the lab. We have, first and foremost, this is also why we are here today. We have 3 Neuroelectrics NOBio 8. These are 8-channel EEGs, which, as we can see in the little picture on the left, in which we have a flexible positioning of the electrodes, in which we can put 8 electrodes onto a participant wherever we choose and wherever we are interested in them. And these EEGs allow us to measure several, let's say, basic indicators. We're going to introduce some of them later, and we're really our I think the most used hardware that we have. We also do have galvanic skin response. galvanic skin response devices from Shimmer, which are pretty standard and well established in behavioral research. I think they have been around since the 1990s, 2000s. So they are a well-established thing that measures emotional arousal. And then we have a section of 3 different ways of eye tracking in terms of hardware-based eye tracking. We have infrared-based eye tracking, so that's screen-based eye tracking with the bar that you can see in the middle on the right. That is an infrared bar that gets connected to the screen. We have pupil labs for mobile eye tracking, and we have VR headsets that are capable of doing eye tracking in virtual environments via sensors. On top of that, as Jorge already explained earlier, Affectiva iMotions also provides several algorithms to analyze biometric data, which is typically camera or recording based. So what we can do is we can do facial expression analysis, which is video based. We can also do video based eye tracking, which is good for the online studies because we can put these 2 elements in large scale online studies. And we also recently tried a voice processing algorithm that is based on the tone of voice, can extract the emotional arousal of a person. So this movement of AI and algorithms is also something that we try to look at in the lab, that not everything is physical sensor based, but that we also take advantage of the advancements of new data analysis techniques. And yeah.
So here we can explain a little bit more about different devices and sensors that we use in class. Jan was just explaining about Affectiva, which is an algorithm that detects through the identification of different face marks, the movement of these face marks by a triangulation process. It can identify the facial emotions that are revealed when a participant is exposed to one particular stimuli. More specifically, Affectiva allow us to identify up to 12 different emotions, like, for example, joy, anger, contempt, engagement, surprise, etc. Okay, and it's a pretty interesting algorithm, especially when we are working with stimuli which are powerful enough to generate these facial emotions. The problem of having a laboratory is that people normally don't feel very comfortable in them. And sometimes when they are exposed, especially if they are wearing these EEG caps and they are exposed to these stimuli, they are not very prone to reveal their emotions, their facial emotions.
Especially when we tell them not to move because the sensors are sensitive to movement, and then they are like... So sometimes the sensors, but in general, you're absolutely right. So if we have strong stimuli, this works quite well.
Yeah, nevertheless, it works pretty well in more natural settings, like, for example, in the online version, where people sit down in their places, in their rooms, whatever they are, but in a more natural environment for them, that it's not really a laboratory. Then, of course, we have the galvanic skin response that allow us to measure the level of arousal of the emotion. We always explain our students that the emotions can be analyzed from different perspectives, not just if they are positive or negative, but we can also measure if they are personal or more social, if people are more likely to share the emotions or not. And also there is the fact that there are some emotions that are more activating or less activating. This is what we in marketing name as level of arousal, right? So galvanic skin response is a very, very simple sensor. Actually, this is a very plug and play device. It's very easy to operate, and what it really detects, it's levels of variation of skin conductivity. Okay, so by tracking this variation, what we can observe are different peaks. Okay, the surge of different peaks that are connected to activation of emotions. The problem of galvanic skin response is that we will never have the information about the balance of the emotions. We will never know if the emotions are positive or negative. The only thing that we know is the intensity of the emotions. These devices, these Shimmer devices, and they also allow us to track for other interesting metrics related to variation, for example, in heart rate, even though we recommend to use electrocardiograms for these purposes. Of course, we have 4 different types of eye tracking. This is something not really very new or different, but I think it's interesting, for example, for some type of studies. Like, for example, we have tested in the use of e-commerce in navigating through different websites. Also, we have used eye tracking in advertising, right? And normally the one that we use the most is the screen-based eye tracking. So the idea here is to obtain, of course, more qualitative information like these nice heat maps that we can generate and that they are reflecting where people is mostly placing their attention to, but we can also extract some quantitative data that allow us to measure not just this heat map, but also the dwell time, time to first fixation for a particular area of interest, the number of revisits that different areas of interest might have. So we can extract really advanced metrics from this technology.
And we can also often identify the order with which people are processing a stimulus on average. Where do they start? Where do they look first, second, third, at least on average? So if we do not understand well where, I don't know, where are people looking at my advertisement? How are they processing it? Are they looking at my brand? These types of questions can be very well answered with eye tracking. And if we have large enough stimuli, also the online-based tool, which is, of course, I don't know, we always say the infrared bar is exact to the millimeter, and the camera-based eye tracking is more exact to the centimeter. That might be a little exaggerated in that sense, but the online-based eye tracking, because you have a lot more variation, people have different quality of cameras. We can never be 100% sure how exact it is, but it also gives pattern. As long as we're not looking for the fine print, but for the big things. Like if I have a big brand logo, online-based eye tracking can also tell me whether people are looking at it or not.
And of course, last but not least, and it is not because we are in a Neuroelectrics sponsor webinar, but this is for us the star product in the lab. It is the one that generates the highest interest, not just for students, but also for companies and other researchers and the faculty. It's the electroencephalogram, the EEG from Neuroelectrics. This is out of question that it's our star product. It's the technology that we use the most. It's super versatile, right? And I guess you are all familiar because we are in a Neuroelectrics webinar. It's basically about measuring the electric activity of the brain, okay, that it's occurring in different areas of the brain. By identifying these different waves, all right, we can identify different emotional and cognitive processes. The typical KPIs that we can extract from an EEG of 8 positions in combination with the Neuroelectric software plus the emotion software are it's the balance of the emotion, if it's more positive or negative emotions, using indicators like the frontal edge symmetry alpha or theta, the cognitive loading, levels of attention, engagement, or more recently also the inter-subject correlation. So in general terms, I would say this is the most successful technology that we have implemented in the laboratory. So let me explain a little bit about our priority with this lab, which was the teaching activity, right? Right now, we estimate that now we are teaching around 27 European credits just in a course of neuromarketing at the undergraduate program and the master in marketing. On average, every year we are training 150 students approximately in the use of neuro and biosensors. And in parallel, we are also leading and supervising different master dissertations and bachelor dissertations. This year, we are leading seven of these projects of students that are doing these projects, and to respond to their research questions, they are using neuro and biosensors, especially the EE, I have to admit. We also have 3 right now PhD students that are using neuro and biosensors and different techniques for their dissertation. That's something that I need to emphasize, is that we are not doing research about neuromarketing. We are using neuromarketing and neurosciences techniques to explore different phenomena related to consumer behavior, like, for example, sustainable or unsustainable behaviors, which is a topic that we are analyzing right now with some of the PhD students. We also offer some specialized training for example, international students coming from other universities in Europe who want to receive a basic formation in neuromarketing. We this year had one intern from Ohio State University, one visiting PhD student from Zaragoza, and we also right now we have one postdoc student from the Tecnológico de Monterrey, which means that in the end we are a very, very open lab. We are always looking for ways to collaborate. We are very open-minded in this sense, and everybody who is interested in using the lab is welcome to explore for synergies, to do collaborative research, to collaborate with other researchers in other countries, in other universities. And also we are, Jan and myself, working on the design of new studies for our school, more specifically a specialization master in neuromarketing and the use of artificial intelligence. Jan, do you want to explain the consultancy part?
Yeah, really quick. So of course, this brings also companies' interest into the market, and basically neuromarketing is something that is seen often skeptical by companies, because there are a lot of companies on the market that claim that they understand things or which aren't really possible. So our approach to this is being a little bit more on the defensive line. We want to combine scientific rigor that we know as researchers, not being neuroscientists, but being scientists in consumer research, with experimental designs that are sort of at least able to show what we want to show. And we have found that companies are interested in this, especially if they know a little bit about the scientific method. So chemical companies, medical companies are more interested than oftentimes than let's say purely consumer-oriented companies. But what we offer basically is a mixture. We can simply open our facilities to anybody who's interested in conducting research with the equipment we have. We would have the personnel ready and conduct the study. But we would also be able to consult in terms of if somebody has a research question, to build the project, to analyze the data, and to construct a report. So from renting simply our facilities, we also offer tailored solutions to it. And to that, I think we give some examples right now to stop talking about what is in theory, but to basically get a little bit into the practice part, what we've done over the last year.
So yes, basically we have obtained in just a couple of years one funding project from La Fundación Ramón Areces. We have a project for 3 years with a value of 30,000 euros. And also a Javor project, which comes from the Catalonia autonomic government for 6 months, 20,000. But we are also obtaining some consultancy projects funded from companies that are collaborating with us, interested into using the lab services, which for us, they are a huge opportunity to generate economic profits, of course, but also intangible profits, because this really generates a network, a collaboration network, where we can also use the students for doing the consultancy projects. And we can establish this win-win-win synergies with them, so students can participate in different projects for solving the problems of some companies coming to the laboratory. And as Jan was explaining, we have right now performed around 4 or 5 consultancy projects in different sectors, like chemical companies, one company in the tech industry. Actually, it's one company that has an online commerce, right? We have also collaborated with the food industry and also with other educational entities. And this is just to mention one example of something that we did with one company from an alumni of IQS. So this is a company that was founded by a former student, and who has this company which is called Protella, and they basically produce and sell these spreads that are basically positioned as being more healthy. Okay, and they come to us to collaborate in the lab to understand some problems that we had with some particular flavors of their products. So all together, in collaboration with the company, the students, the class, what we did is that the students had to design different experiments to solve the company's problems and try to understand what was happening when people was testing the products using different sensors. We used the EEG, the galvanic skin response, pattern and motion recognition, and of course, we complemented all this information with traditional surveys, with an experiment, with some experimental designs. And the results were pretty interesting. Actually, This is a typical emotional cell complex where we can represent the results of the emotional analysis by using this double axis classical representation, where we can classify emotions in terms of the level of arousal and the balance, pleasant versus unpleasant. And what we found out, it was that they had a problem that actually it was reflected on their sales, because the pink version of their product, even though the flavor was pretty much the same of the traditional products, they sold it pretty poor. So with the students, they came with one solution that they proposed to the company, that actually this is an example of what we explained here. They can solve company's problem. They reformulated slightly the product, the flavor, but they repositioned the brand from the pink product, which created, and we identified it with the survey, this perception of not being a very, very natural product. They reformulated a little bit the flavor, and they repositioned the brand in terms of being plus protein, and the flavor changed. Now it was not pink anymore, but it was strawberry cheesecake. And now we're going to explain a little bit about our passion, and Jan is going to be introducing a little bit how we have also introduced Neuro and biosensors into our current and existing academic research to illustrate a little bit the idea of how we are doing this in our research lines.
Exactly. And for that, I'm going to introduce the concept of fear of missing out real quick. And then I focus on the results that have to do with neuro equipment. So that's a little bit the idea. In our world today, fear of missing out has become something that everybody talks about. Everybody has probably heard about the term. And it's something that we experience, that basically some people are doing things or enjoying things or having company, and we feel left out, left behind. And it has typically this is what makes us check our phones every 5 to 10 minutes, because we feel we are missing out on something. Us being constantly connected has led to this phenomenon really being impactful. Psychologists have looked at it. And basically, there have been a lot of studies that found out that FOMO, on the one hand, is very strong in the digital environment, but it also has a lot of detrimental consequences. People who experience FOMO strongly typically are more likely to have problematic smartphone use or social media usage. However, we also see FOMO appeals on social media. So on the one hand, psychologists look at FOMO typically like some people are more likely to experience it than others, and they look at FOMO as a personality characteristics. In marketing, that doesn't really help us. It could help us to segment the market, but we want to look at what does it help, what does happen if I generate FOMO with you in a given moment. So if I tell you, you shouldn't miss out on this, this is your only opportunity, things like that. These types of appeals basically have been connected to impulsive decision-making and very detrimental consumer choices. For instance, consumers take risky decisions when they experience FOMO. Consumers buy non-sustainable products. Basically, FOMO appeals have been shown to make people act and make people act badly. And this is something we wanted to understand better. So we looked into FOMO and NFT purchases. Why? Because on the one hand, I showed two images here. One on the left is the most expensive NFT that was ever sold. And the one on the right is the image from somebody, from an artist, the most valuable, the most expensive painting by a living artist. And as you can see, the NFT generated more revenue. So furthermore, NFTs are a billion-dollar market. They are a volatile digital asset. They democratize art investment in the sense that all of a sudden anybody can invest in original art. And the NFT hype was driven via social media. And what we found basically is that when we looked at OpenSea, the biggest platform for NFT artists, that a lot of artists use FOMO appeals. We identified in the 1,000 most popular artists, we identified around 350 FOMO-related codes in their artist descriptions and in the descriptions of their artwork. And we were able to relate these FOMO mentions towards sales, because on OpenSea you can see how much an artist sold in NFTs in terms of dollar sales or Ethereum sales, and we were able to show that FOMO if artists use FOMO appeals in their artist description and in their artwork description, basically they are prone to sell more. So we ran a very easy online study. We basically let people be exposed to an artwork, and we had a post from a social media, in this case Reddit, that either generated FOMO or not. This is the FOMO condition that I'm showing you. And basically what we found is that people are more likely to invest in an NFT artwork if they experience FOMO than if they're not. So that's the basic storyline. You might ask, why the hell am I telling you this? Because in the next study is where we took this to the lab and wanted to understand it better. What happens in people's minds when they experience FOMO? So we took overall more than 60 students to the lab, obtained about 58 usable participants, used the EEG, used the GSR to measure, in this case, approach avoidance via frontal asymmetry in the EEG. And we used the GSR to measure arousal. And we basically just had two conditions. FOMO, for instance, in this case, investing in NFTs is like investing in the future and you have not joined yet, versus the same artwork, the same Instagram post in which nothing was mentioned about NFTs. Left FOMO, right no. What did we find out? Basically, we figured out that on the left hand, you can see the investment intention is the same. It's significantly higher when we give people a FOMO appeal than if we give people no FOMO appeal. So seeing this, the left one versus the right one makes you more likely to invest in this NFT. On the other hand, we can also see in the middle one, in which I mapped the frontal asymmetry alpha that came out from the EEG. We can see that the frontal asymmetry alpha is more negative in the no FOMO condition. So basically, people have less approach feelings while they see the right Instagram posts versus the left. We had 4 types of these posts, one after the other, to have a minute of EEG data collection. And we can see that on average, the FOMO posts generate more approach than the no FOMO appeals. And we also find that during the FOMO appeal, the participants experience stronger arousal. So in this study, we can basically show that FOMO activate the left part of the brain stronger than no FOMO appeals, and that the galvanic skin response shows us that people are more aroused when they are looking at FOMO appeals versus non-FOMO appeals, and that in turn explains the difference in investment intention. So this is basically something that we would contribute to this. So this FOMO research line is something we started prior to having a lab, but nowadays we are able to show processes that actually show and guide us in order to understand what happens in a participant's mind, brain, to a certain extent that could explain this. So this was about NFTs. We also have a similar research line that goes about cryptos. Is there an upside to FOMO? As I said, FOMO is typically problematic. FOMO makes people take risky decisions. FOMO is so far only been shown as detrimental and making people things do that they might regret later. On the other hand, FOMO is also driving cryptocurrency sales in a similar way that they drive NFT sales. And what we see here, cryptocurrencies have one major problem. They use more energy. For instance, Bitcoin uses more energy than Norway, as you can see on the image on the right. And the alternative, the sustainable alternative cryptocurrencies don't sell that well. So we wanted to see if we can sell normal cryptocurrencies with the FOMO appeal, can we also sell sustainable cryptocurrencies with a FOMO appeal? That was basically the idea of this study. And first of all, we wanted to also understand, what do FOMO appeals do when people buy cryptos? So in that sense, we gave people a FOMO appeal or a non-FOMO appeal, similar to the last study in the lab, and we let them buy cryptocurrencies. What we found out is that FOMO makes people more likely to buy cryptocurrencies, and that interestingly, the cognitive load increases in the FOMO condition versus the no FOMO condition, and also the squared cognitive load. And actually, we find that the squared cognitive load in an inverse U relationship mediates this effect. I can go into more detail in the question what that exactly means, but basically we can show there's an optimal way. FOMO makes you think a little bit more. If FOMO makes you overthink, it becomes unproductive again. but we understand that FOMO triggers cognitive activity that in the no FOMO condition we cannot observe. Now, can we sell something sustainable through a FOMO appeal? We gave two exact same coins, a regular coin and a green coin, one that is sustainable. And we showed people a FOMO appeal or a non-FOMO appeal. So a 2x2 online study. In this case, basically what I'm showing you is simply the main punchline of the study, that on the left hand, for the normal crypto, FOMO appeal makes you want to buy crypto. If the crypto is green, the FOMO appeal is actually detrimental to your purchase intention. So this is something that we basically show that FOMO appeals do not work for sustainable and rational investment choices. And now we better understand this. We took this to the lab again, got 50 participants, and we gave everybody a FOMO appeal, not have 100 people in the lab. And we then let them have randomly the normal crypto or the green crypto. So when they see FOMO, actually, the normal crypto is more likely to be bought than the green crypto, as the previous study also showed. So FOMO works better on a normal crypto than on a green crypto. And again, we see a higher cognitive load in the normal FOMO condition, in the normal crypto condition than in the green crypto condition, somehow replicating our previous results, even though this one, I have to admit, is not statistically significant. And in this case, we were also able to engage the module of inter-subject correlation, and we can see that people they reply in a more react in a more similar way, looking at FOMO and a regular crypto than towards FOMO and a green crypto. So these findings sort of, again, give us some insight that there are different reactions in the brain if people are exposed to a FOMO appeal, that in part can explain the differences in purchase intention for crypto. So our lab here helped us to better understand the FOMO appeal phenomenon, which we have investigated in various ways.
So yeah, making a little bit of a spoiler, Jan, here. Here we go with our tips to start this incredible journey with the fellowship of the ring, right? We have tried to summarize this in a very short way, because it has been a huge experience for us in these last years, but we wanted to emphasize what we consider to be more important for people like us, for academic researchers who are considering these technologies in their academic activities. From our perspective, using neuro and biosensors, it's a great opportunity for teaching, for learning, for designing super appealing activities for our students, for our schools, but that can be applied to many disciplines. We are experts in consumer behavior. We work in the area of consumer marketing, right? But this can also be applied to so many disciplines that are related to business: advertising, communication studies, graphic design, digital marketing, behavioral economics. I feel there are really, really great opportunities in many, many disciplines in the economics and business area. To be honest, and probably this is one of the largest mistakes that we did at the beginning, even though this might sound very, very expensive, it is not really a great need to spend a lot of money in a laboratory. To be honest, what we need or what you need, it's one device for all the different technologies that you are interested in, and learn how to operate with them, right? So at the beginning, I would say, even though it might sound like a large investment, it is actually not that much. And there are actually, if, for example, in Spain, we have these funding opportunities from different calls that allow you to obtain some money to invest in these infrastructures, if it's well justified that this is something that is going to be used for teaching or scientific purposes. In general terms, I would say we have spent like 1 year learning how to operate properly with all the devices and technologies that we had in the lab. Actually, they are not so complicated to operate, but the problem is that at the beginning, everything it's like overwhelming, and you really need to simply save 1 year of your academic research time to learn how to operate with this. Obviously, there are going to be a lot of questions and a lot of problems coming up, But to be honest, both neuroelectrics and emotions have these customer success representative guys that are extremely help you and that really offer a great service in situations where you have any type of problem, question, technical or scientific issue. What I would suggest, and that's a little bit the fellowship of the ring, is that the more you are using multidisciplinary teams, the better it's going to be for your research, because you really need advanced skill in database management. We are dealing with big data, all right? And if you have one scientist in your team, that's going to be much better to operate with the EEG. So I would emphasize, if you are in a research group, try to rely on other researchers, other academics from other areas or disciplines. So for us, the lab, it's been about looking for synergies. We are continuously looking for opportunities to collaborate in the laboratory, not just because we are getting funds from company and we do some consultancy projects, but also the fact that companies are directly engaged collaborating with us in the lab. It's also opportunity for the school and for the students. As I said before, for us, teaching is probably the most relevant activity. Right, so we are in contact with our alumni, with our students, with our business network, with different public agencies, right? That might be interested at some point to collaborate with us. And as for the academic research, I would say that if you want to start using neuromarketing tools, the idea is how can these sensors can help in your current research lines. There is a vast amount of studies using these techniques, but the question is how these techniques might help you currently in what you are doing in your academic research. That's what is more important for us. We have been in this lab for almost 3 years now, and what we are doing from the consumer behavior perspective is trying to foresee how we can use these super comprehensive technologies into our existing research lines. We are not opening new research lines. We are not creating something really new from scratch. What we are trying to do is to look for the fit between what we are doing and what the neuro and biosensors can offer to us. And in the end, the Neuromarketing Lab for us, it has been a great opportunity for creating many networks. We can apply for joint funding applications with other universities. We have a lot of synergies with other laboratories located in other places, in other countries. We exchange PhD students that go to other laboratories in the context, for example, of AR or VR, augmented reality or virtual reality, and other PhD students that are interested into having one period, some months with us in our laboratory. And it's about trying to elicit these knowledge transfer activities between different institutions. So, in summary, we really encourage you to go into this interesting field. All right, I think we have explained what we wanted to explain, and we are pretty much out of time. So, yeah, I don't know, Jan, if you want to add something, or we can go to the questions and answers.
I would say we go to questions and answers. If there's anything more to say, in case you want to reach out to us, feel free. This is our team, by the way. These are our PhD students, person from tech transfer, and other researchers who are certified and in doing research in our lab from our research team.
Okay, perfect. Thank you very much, and congratulations on the lab of everything that you have created and what you are doing. We are really impressed, and this is time actually for questions and additional questions, because we have already about 10 questions I can see from audience. To start with, I have like very simple question regarding the subjects in terms of studies, projects that you are doing, for example, for external customers. And I have seen one that there were like 500 subjects. How you are getting subjects for your study? what I understand that there are students, but there was one with 500. So this is like a very, very representative sample.
That's an online study, Rafa.
Okay.
Online. Basically, here what we did was we wanted to integrate emotion services using eye tracking plus Affectiva facial emotion recognition in a large sample. So we integrated a panel of consumers in Spain, which is very popular, which is called NetQuest. I don't know if you're familiar with, but it's basically an online panel of people that respond to different surveys or that they participate in different experiments. It would be a little bit like Amazon MTurk, but I would say it's more serious and more rigorous than the Amazon MTurk, right? And it was an online study, right? So the success here was to fully integrate both services, which was actually, from a technological perspective, very complicated.
Yes.
Okay, perfect. Thank you. We have a question from the audience. You can open the Q&A if you want, guys. The first one actually is from the beginning of your presentation, and it's more technical. When you were presenting eye tracking system, we have used a Tobii Nano, question from Sam. We have used Tobii Nano bar for screen-based eye tracking in the past. And one of the problems we experienced was the nano bar projected infrared light onto the participants' faces, which interfered with the Affectiva analysis. Have you had similar problems with the Smart Eye Aurora? And if so, how do you mitigate this?
Never had a problem, to be honest.
I have not seen the Affectiva with our eye tracking bars being any, like we did studies with the Affectiva and eye tracking, and we have done studies with Affectiva without eye tracking. So we have had studies where the infrared was on and where it was off, and I haven't really seen a difference, to be honest. So it seems to be that particular eye tracker, or at least I haven't seen it, all I can say.
Perfect, thank you. The next one is from Hugo. And actually, you were talking about collaboration, connection, networking. So Hugo is a neuroscientist, MD, physics engineer, and he has been working with a team on neuromarketing, consumer neuroscience project with industry using solutions you presented like fMRI, models, different scripts. And he is asking for the partnership, some together projects that you can do, cross-border international projects, and you have email in the Q&A. So this is a perfect opportunity.
Thank you very much for Hugo Alexandre and taking notes, actually. So we will be with you. Thank you very much.
Actually, Hugo was asking
if you have something in concrete, or otherwise we're happy to always talk.
So there is actually there are additional questions from Hugo and comments. The first one, if you'd like to do an intervention to modify the FOMO response and also testing that in short selling, please let me know. Okay, so this is under the suggestion. If you are using CL, my understanding is cognitive load based on the theta EEG.
I think for the cognitive load in that study, we used the PZ and FZ electrodes together. So it's not only frontal central region, but also parietal central region. So a little bit more in the top. So, but we definitely use the frontal part as well.
Okay, and another question or suggestion actually from Sam was, what design principle would you recommend to mitigate EEG artifacts when it comes to building your own EEG lab or own lab actually? I can take this question if you want. Actually, we are EEG experts.
Yeah, exactly.
Or we can contact Sam actually. So there are different factors can affect EEG recording. And if you have the opportunity actually to build from the scratch the lab, so there is an option to have a Faraday camera. So it's actually the camera that it's filtering on noise from the outside, and it's from the electromagnetic point of view and also from the auditive point of view. taking care of the location, electrical cables, where will be located, for example, elevator, electrostatic field, electromagnetic fields. So there are many factors that can influence and generate some external factors that can be avoided. And this is the same as, for example, for a laboratory where you are doing neurophysiology, like from the medical point of view when you apply. So there are clear guidelines how to build this lab or neurocognitive lab to have experiments without EEG artifacts. So this is this external part of artifacts that are coming, but there are also the internal part coming from the subject. So there are other instructions for the subjects to avoid muscular artifacts, movement artifacts, eye artifacts, or whatever. But those are like the basic things. But we can contact Sam actually and provide additional details regarding EEG. Another question is, have these students had, let me check which students, experience with EEG before attending this class, or is this all new information? If it's all new information, how do you successfully teach them with a semester? In other words, how in depth are you teaching the students how to use the EEG, such as recognizing successful signals, and if the signals have some interference, how they should fix it, creating the study and interpreting? Actually, this is not only for the EEG, I think this is a question general regarding the techniques you are using.
Yeah, I would say that our neuromarketing course, it's a neuromarketing course, which means we have 60 hours normally per course, which means that the time we are dedicating to the EEG, it's normally, I would say, theory approx 6 hours plus 4 hours of demonstration, and then they collaborate hands-on in a project, so they learn how to operate with the EEG, how to apply it, and how to use the different sensors. We don't go much in depth. Of course, we teach them what an EEG is, how to interpret the data, how to transfer the signal and do the Fourier transformation, how to interpret it, and how to see it in the screen. And we explain about the main KPIs that we can obtain, how to interpret. But obviously, this is not a neuroscience course. It's more a neuromarketing course. So the depth, it's the one that we can have, considering that in the same course we explain the EEG plus galvanic skin response, eye tracking, facial emotion recognition, and we dedicate around 20 something hours to the project, data analysis, design of the experiments. So I would say, if you're a neuroscientist, you would consider it probably superficial, but from a neuromarketing perspective, I think they have a good introduction into the method, at least to understand what they are dealing with.
Yeah. The students that really understand this are the ones that collaborate in the thesis with us. They are the ones that in the end are capable of actually collecting data themselves. They might not be able to analyze the data without assistance, but they are guided by PhD students and partially by us in the data collection, and they get to a point where they actually can operate emotions and data collection with EEG independently from any help. But our in-class students might have touched the device, might have done it once, but they cannot absolutely do it. But they know what the KPIs are, they know what the device can do, what it can do. That's more or less our approach.
Perfect. Thank you. We have another question from Sam. If you could expand a bit more on the consultancy projects you are doing for chemical and medical companies.
This is Sami Balls. I think this name rings a bell, right, Jan?
Yeah, it does. Hi. To be brief, the project is ongoing, and it's just what we find is that chemical companies, medical companies often, let's say, speak a scientific language. They understand what it means to build a randomized controlled trial, for instance. So you immediately speak a common language. Somebody at a fast-moving consumer goods company, if it's not Procter or not Nestle, and then they will have these devices in-house. If it's a smaller company, they will not understand what you're doing. So we have figured it out that it's easier with these companies to set something up. I don't know how much I can say about the chemical company's project right now. Basically, what we're doing is we're classifying the emotions certain smells are triggering, and if the reported measures and the emotional measures in the lab correspond or where not, and then maybe look at why. But that's a little bit what we're looking into, where we found that our opportunity is often that they have labs, but on a small scale, and we have the raw material of the participants, so we can scale up. We can ask more than 100 students to come by in the lab in the semester. So this is why we are interesting for them, because they do studies normally with 15 people or something like that. So
Okay.
they are actually more advanced than we are in this case, but we can help because we have access to participants.
Okay, and do you have any device or tools that is delivering like others, or this is just someone is
They do,
testing?
we don't.
Testing. Okay.
We did the classic perfumery type testing with paper strips. If they're olfactometers that they have give different results than just the regular, because our situation is more like in a supermarket where you would give it a try and then see if you buy it or not, right? Well, the
real
olfactometer
world,
is
yeah.
more a simulation of how it will smell in your house. So that's the difference.
Yeah, makes sense, makes sense. And the last questions regarding virtual reality that you were mentioning, and virtual reality eye tracking and other projects that will involve virtual reality. If you have introduced it in your lab, or you're planning to introduce in your lab?
We are planning to introducing it in the lab, okay? Especially because VR, it's extremely time consuming when using the eye tracking. So we have tested it, we know how it works, but right now we have not developed any project, any specific project on this. Actually, what we have seen is that there are some studies using not just eye tracking, but also in combination with VR and galvanic skin response. There was an interesting paper that was done about how people react. Galvanic skin response actually reacted in virtual environments in public transport, like for example inside a bus or the subway during the pandemic, where people was coughing, for example, and the place was crowded, and how people felt more nervous and would react in situations like this. So yeah, there are some research groups we are aware of that they are doing this kind of research, combining VR with GSR with eye tracking. We have not get to this point so far.
Okay, perfect, perfect. So this was the last questions. Thank you very much for the presentation. Thanks everyone for your questions. Thanks to our guest, Jorge and Jan, from Ramon Llull University in Barcelona. So thank you very much, guys, and hope you will see us again for the next webinar. You can find information regarding our webinars on our webpage, neuroelectrics.com, where you can get more information regarding upcoming webinars. So thank you again, and have a great day. Thank you, Jorge and Jan.
Thank you. Our pleasure.
Thank you
very much for the invitation.
Thank you, and see you soon. We'll be visiting you soon.
Yeah. Bye.
Thank you.
Bye.
Thank you.